Let's continue with important characteristics that actually dictate the propagation of light in an optical fiber cable. And we started looking at reflection, just a simple idea of reflection. Refraction, let's continue with refraction. So I said if we assume this is an interface between two medias, and let's say on top we have air, and the lower medium, let's call it glass. So again we have refractive index N1 of air, and we have refractive index N2 for glass. What happens? We say when light travels from glass to air, it's going to bend. So if this is our normal, if light travels across the boundary like this, it's going to bend. This is the so-called refraction. The ray of light has been refracted. Now, I've said one of the most important things here that actually dictates refraction is the so-called refractive index. Each medium affects light differently. We talk about glass. The way glass affects light is different from the way the surface like a wall affects light. It's different from the way a liquid sample like water affects light. So light is going to be affected differently as it propagates in different medias. Because of that, the characteristic or the property that actually governs that is the so-called refractive index, N1 and 2. N1 is for air, N2 is for glass, just for notation. What is refractive index? Refractive index is actually a ratio. So N is the ratio of speed of light in vacuum, speed of light in vacuum divided by speed of light in a material medium. That is N. Refractive index is the speed of light in vacuum, which we all know. We know the speed of light in vacuum is C equals to 3 times 10 power 8 meters per second. This value was predetermined by the early pioneers of light and the early scientists who actually worked with light. So it is a constant. So speed of light in vacuum divided by speed of light in the material medium, we get refractive index. Remember that always the speed of light in air is the highest speed that light can have. The speed of light in air, I repeat once again, is the highest speed that light can ever have. When light travels in different medias like water, glass, and so on and so forth, its speed gets reduced. Because of that, in our numerator here, we have speed of light in vacuum, which is actually the highest speed that can be attained by light. It means refractive index can never be less than 1. The refractive index of air, for example, N of air, is 1. Refractive index of air is 1. So refractive index can never assume a value that is less than 1 at this stage. For example, we have water. The refractive index of water is about 1.33. Refractive index of glass, like fused silica, silicon dioxide glass, the refractive index is around 1.49, 1.5. What does this tell us? The denser the material, the higher the refractive index. The lighter the material like air, the lower the refractive index. So these are important things to understand. A very important concept is the speed of light in a material medium can never be above the speed of light in free space. That is something we should take into account as we move further. Thank you.